Okay, so module 4. This gives us, in this chapter, we're going to learn about business continuity and backup and archive. So, what happens here is in business continuity, it's an integrated enterprise and worldwide. So, what you're trying to do is you're trying to make sure that the business is a continuous process. So, what you're doing is when there is a failure, you have to see that how you're going to recover and respond to the failure. So you're taking proactive measures such as impact analysis, risk assessment. You're trying to take backups. You're trying to replicate and then keep the data beforehand. And then how do you reactivate from the disaster? How do you recover from it? And how do you restart it once again after this thing? So this to ensure that the information availability is required. That is, you're making all your information available. So you're making it present. I mean, what is, then we'll go and ask what is information availability. So information availability, okay. Information availability is ability of the infrastructure to function according to the business expectations during the specified operation time. This means that if your business operation is from 9 to 5, you're making sure that it is available from 9 to 5, like every single day, or as specified. Like if you're working from Monday to Friday 9 to 5, then from 9 to 5, from Monday to Friday, it should be available. Business, that's how what your business expects you to do. So you can check your business availability in terms of RAT, okay, that is your reliability, accessibility, and timeliness. Reliability is when uh, your reliability is when it doesn't fail many times, and then you can trust the system. Accessibility is that it can be delivered to the right place to the right user. So the time which is sent is, you have a system uptime, and then you have a system downtime. So system uptime is, so now if a failure happens, now that is your system downtime. And then when you restart the computer, you recover from your failure and then you restart it. That is your system uptime. That is when your system is accessible, that is uptime. And then when it is not accessible, that's your downtime. Then you have timeliness. What is timeliness? That it should be with open within that window. Like I said, like if you tell 9 to 10 p.m. only, 9 a.m. to 10 p.m. if online business is open, it should be present over there. That is, you should be able to keep the website open. Like you have Google Sheets which close, it should be able to close on time, right? It shouldn't vary in timings. Then you have this also comes under information availability. You have to write the causes for informations being unavailable. So first draw this diagram. Less than 1% is disaster. Unplanned is 20%. Planned is 80%. So what happens in planned is, you already know what you're going to do in this maintenance. So all this maintenance, installing new hardware, you're taking backups. That time you can't. Your system will be down for a while, right? So that is your planned outages. And then you have unplanned outages. That is when your database gets corrupted, or a component failure happens, or there are human errors. Disasters, they can be natural or man-made. Like if there's floods, earthquakes, and that is exceptions that your business can have outages. Consequences of downtime. So what are the consequences if your business is facing an issue? First, you check you have loss of productivity, loss of revenue, poor finance performance, and damage to reputation. So this only you have to write in detailed over here. So what is loss of productivity? Is when, see, now you're already paying people to work for you, right? So if they don't do work because your system is down for maintenance, there is a lot of loss of productivity. You're paying them, but the work isn't getting done. You're just relaxing. So that is loss of productivity. Loss of revenue is when you have to you have a lot of billing losses, investment losses, direct losses. So everything related to money. Finances, it's related to cash flow, discounts, payments, payments and stock price. So this goes financial poor financial performance is it affects your revenue recognition. And then you have damage to reputation. So once in the market you get a bad reputation, your reputation sticks with you, right? So that is what happens. Then what you're doing is now you have to find average cost of downtime per hour. So how you're calculating is average cost of downtime per hour is equal to average productivity lost per hour plus average revenue lost per hour. So that's your average cost of downtime. So revenue plus productivity, both you have to calculate. You can't just calculate only on basis of revenue, right? And then productivity loss per hour. How do you calculate this productivity loss per hour? Is you use total salaries and benefits which you are giving to the employees divided by the average number of working hours per week. That's how you get productivity loss per hour. And then revenue loss per hour, you get it by giving total revenue of an organization per week and then dividing it by the total number of hours the organization is working, is open for business. Then you have measuring information availability. That is, information availability relies on physical and virtual concepts. So how do you measure it? So you have proactive risk analysis being performed as part of business continuity planning process, and considering the components. You have failures and then how you recover from it. So you have the two measures, that is MTBF and then MTTR. So you need to write about MTBF, that is your mean time between failures. So and then you have MTTR, that is your mean time to repair. Okay. So what you're doing over here is you draw this diagram. Okay, you draw this diagram where you have a timeline of incident. So your incident happens, then you detect the incident, then you diagnose the incident, you repair the incident, restore the incident, recover from the incident, and then again until the next incident. So this time is called time between failures or uptime. Okay, so that is your MT. This is your when you take mean, when you average this over a period of time, you're taking this divided by how many ever times you have in a cycle, 4 or 5 or whatever. So that is your average for that. Then you have okay, when you have an incident and then you're detecting it. So this part is called detection elapsed time. So you don't know what happened over there, so you're trying to figure it out. So detection elapsed time. So after detection, you're diagnosing it. So that is your response time. When you diagnose and then you have to you repair it and then you have to restore. So until restoration, totally it's called repair time. And then from restoring to recovery is called recovery time. So what is the incident to recovery is called time to repair or downtime. So this is your MTTR. So this is also an average that you have to take, and then you have to give this diagrammatic explanation. Your information availability is the time period the system takes, is the condition that is performed. So what you're doing is information availability is system uptime divided by system uptime plus system downtime. That is your total system time. Okay. So you can use this in terms of MTBF or MTTR. So that is what you're doing here. Uptime is nothing but your MTBF, and then your downtime is nothing but your MTTR. So what you're doing is you're adding it both and then giving the total. You have BC terminologies as the next important part. What happens here is that the disaster recovery. This is the coordinated process where you restore the system and the data and infrastructure are being made sure that the event of the disaster is being recovered. So what you're doing is you're restoring a previous copy of data and then applying logs or other necessary processes that can bring the data back to a point of consistency. So once the whole process is completed, it is validated to ensure that it is correct. what happens when you when the disaster restart happens is, after the disaster, you're restarting the business with mirrored consistent copies. So you're taking, like, you're mirroring the copies, you're keeping a backup, and then you're of your data as an application, and then you're restarting your business. uh, Recovery point objective, that is what happens here is that you have a point where you can, until one point you can tolerate data information loss, which is manageable. So that is what is happening. So it says that it's a point in time where it has to be recovered. All these data and all must be recovered from an outage. It defines the amount of data loss that a business can endure. So it signifies, if it has high tolerance of information loss in the business, it has a larger RPO, that is recovery point objective. And then you have RPO also happen RPO also happens on basis of frequencies. That is, you take it 6 hours once. It depends on the size and the backup that must be taken. So you have RPO for 24 hours. That is, this endures backup and is created an offsite tape drive every midnight. So you know WhatsApp, right? In WhatsApp, they do backups at around 3 a.m. or 2 a.m. in the morning. So that is 24 hours RPO for WhatsApp as an example. So we saw 24 hours tape. Now we are seeing RPO for every hour. That is, all your shipping details must be shipping database logs, and that has to be. So if your all your updates and information that you're sending, if the data is lost, then it's little tricky to get back all the information and then make sure everybody gets the correct inputs. So what you're doing is um, you're taking backups every hour for recovery. And then what you have is RPO in order of minutes. So this happens, mirroring of data happens asynchronously to remote site. Near zero RPO, this is the mirror mission critical data that happens synchronously to a remote site. So you have recovery point objective and recovery time objective. So you're seeing, if you can, in what and all happens over here is your mirror your so what happens here is you're taking tape backup. Here your weeks, it takes almost, you have to write seconds, minutes, hours, days and weeks. So you have tape restoration takes a lot of time. And then you have periodic replication, that is, your disk restoration takes a little bit of time, a little less compared to tape restoration. Then you have asynchronous replication, that is your manual mitigation. Then you have synchronous replication, here you have global clusters. Then you have recovery time objective. So the time within which it's like the time it takes to recover after the disaster has happened. So the amount of downtime of a business can endure. That was the amount of business loss of information was the previous one. In recovery time objective, we have the amount of downtime a business can endure. So what you're doing is, it can take for 72 hours. That is, restoring from backup tapes takes almost up to 72 hours. 12 hours for restoring tapes from a hot site. This is at a cold site and then a hot site. And then few hours if your user data vault to a hot site. And then you take a few seconds if you have a bidirectional mirroring enabled. So you have your BC planning life cycle. So what happens here is, you have to draw this diagram. Start with design. You design and develop. You implement your design. You test and train your you train your design, and then you maintain it. You establish objectives, like what is your main goals to achieve, and then you analyze if it is matching with your goals. And then you again, if it is not, then you again go to design and developing it. So you have several established objectives. That is, you determine basic requirements, the scope and budget of the archived requirements. So here what we do is, we establish the requirements and then you create policies and all. So your first step will be establishing your objectives. So what you have to start is, you have to actually start from here. You establish objectives and then analyze what our objectives are. Train and develop a model accordingly. Then implement the model, test and train it in the end. Then you have analyzing, that is, you collect information on data profiles and business processes, infrastructure and dependencies. So you identify what is analyzing? Yeah, you identify the critical business needs and then assign recovery priorities. You create risk analysis. So what you're doing is, this is like, you're doing this for business continuity. In case you have a what you'll do in beforehand, that is, you have a business impact analysis that is done, and then to make sure that all your data that is safely backed up or recovered later on. Then you have design and develop. So you design protection strategies, you develop infrastructure, then you develop contingency scenarios, you have emergency responses, then you have recovery and restart procedures, all of this. So you're defining the term structure and assigning individual roles and responsibilities. You're giving them individual roles and responsibilities on what they should do. Then implementation. So implementation of risk and risk management and mitigation procedures include backup. What you're doing implementing me, that is, you backup, you replicate, and you manage your resources. So you're making sure that all your data is saved safely, and then your data recovery sites can be fully utilized if the disaster affects in primary data center. So your first layer of data center, if your disaster occurs there, then it can be easily managed. And then you implement redundancy for every source, that you make copies and then you keep it. And then you have training, testing, and assessing and maintaining the database. What you're doing is training your employees who are responsible for backup and replication of business criteria of business critical data on a regular basis. So what you're doing is, you're training your employees on what they have to do in case, if you, what a backup team is in a company is, they'll be trained to make sure that you have enough backup, and then you know what to do when the failure occurs. Just because there is no failure, it is not like they'll not leave them untrained and all. So they'll train them on that. So they'll train them on emergency responses, what you have to do. It's like, first, if if your files are getting corrupted, what is the first thing that you have to do, your emergency situations. And then you assign recovery teams and recovery procedures that they have to follow. Then you have damage assessment and process of recovery. Now, if the damage is already done, you analyze it and then you make a recovery plan, right? So that is what you're doing here. Then you're testing your business plan regularly to check its limits. So you keep checking it often. Next topic is failure analysis. Here we have a single point failure that refers to that can terminate the availability of an entire system or an IT network. That is, each component must function as required to endure the data availability. So if one part also fails, then there is a whole chance that your whole network is down. So if you have, your client is connected to the server through an IP network, then the server is connected to the storage array through FC connection. HBA is installed at the server, sends or receives data from to and from the storage array. And then you have this can be what is that? Similar to single point failure. How can you explain single point failure? Okay, so you have a VM, that is your virtual machine, and a hypervisor. You have a HBA controller or NIC on the server. So I'll explain the diagram and then you can write it in your own words. You have a client, you have an IP switch, you have a server. In server, you have to always remember that you have a hypervisor, and then you have virtual machines. You can have many virtual machines which each have OS and applications of its own. So, and then you have FC switch and storage. So any point, if your failure occurs here, then since it's all in a straight line. If a failure happens here, your flow is broken here. If it's broken here, you cannot go on to further steps. Same thing with any other device. Either client fails, then you cannot do then the whole thing is useless. Then if your IP switch fails, it's like it's a failure. So one point of failure or single point of failure is what is happening. So now you got to know what a single point of failure is. So how do you resolve that? So what you're doing is, instead of having a straight line of things, you make sure that you have to mitigate it, you design it with redundancy. That is, you keep an extra copy so that if a failure occurs in a straight line, then you can rely on another source so that the process still continues. So this will fail only if all the components fail. Okay, so it's like you already have a backup. If the whole system fails, so like for example, you have two IP switches. So what happens here is, if you have two IP switches and if one of them fails, this is the redundant one, that is your mirrored one. So you use this to go. So it's not you cannot have a single point of failure. Then you have data centers that that they have fault tolerance, and then you build it with fault tolerance for uninterrupted informability. Okay, and then you give an example. Then you have configuration of redundant switches for switch failure. So you keep extra switches also, and then you have multi storage area ports to mitigate a port. So now when you're transferring data, you transfer it to through a port, right? So this port, or if it fails also, your single point of failure is it occurs. Okay, so what you're doing is you have another port, so that your port failure is not a reason why. Then you have RAID and then hot spare configuration. So these ensure continuous operations happen. So it's like you have disks of arrays which are present, and then you make multiple copies. You have a parity bit which stores one mirrored copy of all the data. This will be a parity bit in RAID. And then you have implementation of redundant storage array at a remote site to mitigate. So you're keeping it at a remote site, because if there is if there is a failure in a particular area, if it is there and the data or the storage happens at a remote site, the extra copy is stored at a remote site, you can access the data through that. You don't always have to follow one method. Then you have implementing server clusters or fault tolerance mechanisms. So you're trying to implement as much as fault tolerance mechanisms, and then clustered servers exchange a heartbeat to information. So then you're implementing VM fault tolerance also, because in storage you have the VMware, right? So you're using VM fault tolerance also. So two VMs can be kept in synchronization with each other in order to perform successful failover. So this is the recovery, restoring single point failure thing. So you have client, and then you have two IPs. Okay, you have redundant network also. You have a redundant one, and it goes to two servers. So from both your IPs it goes here. Both your IPs it goes here. So then you have a NIC team. And then you have redundant ports. You have two ports over here connecting from this to your FC switch. You have two redundant FC switches, and then both of them connect. It gets connected from both of the servers, and then both of them get connected to your storage array. And then you have a remote site storage array. So your storage array is usually stored in a remote site. Okay, so that is for your restoring single point of failure. Then other than the topics, you have two more topics, that is your multi-pathing, and then you have your BC technology solutions. Multi-pathing hasn't been asked many times, or it hasn't been asked in the past papers, so we'll be skipping that for now. Then you have so you're analyzing the business impact outage and all. So what you're doing is, now you had your technology, so finding solutions for what you'll do. So you're creating backup, and then you're storing array based replication in local place, and then you have a storage array based replication in a remote place. What you're doing in backup is data is backed up in form of RPO, RTO, and frequency of data changes. Your data is made sure you have a backup of it, and you're making it available. Storage array based replication, what happens here is, the data can be replicated to separate locations within the same storage area. So you're using it in separate locations. You have one area, you have you have one storage array based, this is storage 1, and then you have a replication storage R, that is your storage application. Both of them happen in the same area. What you're doing here in the third one is store in a remote area. So if this is your area where you access your storage, you have a storage over here, and then remote area. If this is in cache, for example, CAC cache. Okay, if this is in cache, then you have one more copy of stored in another place, that is your remote area. You have a storage which is stored in your remote area, which may be in your main memory. So if you can't get the details from cache, what you're doing is you're going to the main memory and then you're accessing it. That is what your remote access means. So for module 4, these are the 8 important questions which will generally be asked in the past papers. What you're doing here is you have a so here we have done BC terminologies. Uh, that is all your RPO, RTO, and all we did, right? So that is your BC terminologies. Then explaining fault tolerance mechanism or failure analysis. This is your single point failure analysis. And then you have BC and its life cycle. That is your you find your objective, analyze, and then take backup. So that it is the circle. So what BC life cycle is the circular diagram of 6 things, and then it just closes. So these are there for part 1 of module 4. Part 2 will do for restoration and archive.